Excellent. So once again, welcome everyone to the Handy Tips Using At-Risk webinar. Today we're going to be looking at various little tips and tricks in the software, things that help make your life a little bit easier. And some of these are sort of hidden in the options, or not a lot of people are aware of all of these things. So hopefully in the next 45 minutes to an hour, I'll be able to show you a few things that can really reduce the aggravation of using the software, as sometimes there's things that you do over and over again and you wish there was an easy way to do them, or a way to have it set up so that you don't have to continually make changes to the software. And usually there will be. The first thing I'll do is get rid of my fabulous writing there. And let's get started. I thought we would start by looking at various graphing options that enable us to obviously, if you like, the key to getting our point across after we've run an analysis is not just tables of statistics and reports, it is pretty pictures. Graphs, graphical information, very powerful, but we might find that the standard graphing that appears isn't necessarily precisely what we would like. So what I'll do is I'll open up an example. Let's get the little say something with financial modelling. There's lots of outputs in this model. Great. So here we have a simple MPV model. It has multiple inputs and outputs. The first handy tip that I'll mention is that if you want to know exactly what you have open and where everything is, the model window button is a very useful one. I know that there aren't a lot of people out there that use it, but the model window tells me a few things straight away, such as how many inputs and outputs I have, correlation matrices that I have, and also, very importantly, the location of everything. So as I select any of my outputs or inputs, At-Risk will actually navigate to that part of the workbook, or indeed that workbook if I have multiple workbooks open or any worksheet in there. So it's a very easy way of getting around the spreadsheet from an at-risk point of view. Now what I will do is run a quick simulation so we can get some results and have a little look-see. So I'll just run 1,000 iterations. And while that's running, another thing that you'll note that we can do is pause, stop, and then restart our simulations. This can be very useful if sometimes there's a setting that we don't want to have on our run. Maybe we've got graphs appearing, or the Excel spreadsheet is updating in the background. We can pause the run, make those changes, and then restart. Okay, so now I've got some results here, and I might look at, pardon me, say my cash flow in the first year. Most people are familiar with the Browse Results button. This is the same charting interface that appears if I had turned on the Show Automatic Graphs as Outputs button. And here is my result. Easy. Other ways of getting graphs are to right-click a cell and then use the At-Risk mini toolbar. This has the advantage of not just producing a chart, but it's a free-floating chart. I'm not in Browse Results mode, and I could get now a chart of another output and show it simultaneously. So one limitation of the browse mode is that you can only see one chart at a time. Now I can have multiple charts open, I could have different sensitivity analysis results for the same output, and so on. But what I wanted to start with is by showing you our overlay functionality. From any graph of our output, you may or may not have ever clicked on this button before, which is the Add Overlay to Graph button. If I click that, I can select any other outputs I wish to overlay, and now I have an overlay chart. Quite a simple way of creating a chart to compare different outputs, maybe different groups, different categories, pardon me, different business unit total costs, and so on. And it's that simple to create an overlay. I can also highlight several cells, go to my At-Risk mini toolbar again, hit the overlay button, and I'll create an overlay of those multiple outputs. So again, a very easy way of getting an overlay chart for comparing results if they all happen to be near each other on the spreadsheet. However, there is another, even, I guess if anything in risk analysis is going to be called fun, this is fun. A fun way of producing overlay charts is through the results summary. Again, this is a button that not a lot of people click. Generally, the browse results option is what comes up, and that's where people get their graphing. But you can see here in the results summary, I have access to simulation results for all of my outputs, as well as simulation results for my input cells as well, where I can compare my theoretical chart or theoretical distribution overlaid with the actual simulation data. But in the outputs itself, I can highlight multiple outputs by pressing the Control key and clicking on these different cells. So just like selecting multiple Excel cells, and in the same vein, I can use the Shift key to highlight a collection of distributions at the same time. Pardon me. Then I can create an overlay. And now I've overlaid all 4 of those charts simultaneously. But the fun way that I wanted to do an overlay was to use the results summary to create a chart. Again, not a lot of people are aware that this little thumbnail can be clicked, dragged, and dropped off the window to create another chart of my output. If I want to overlay another output on top of that, say the income for year 7, I simply click, drag, and drop it on top of my initial chart. And that's the overlay. I can click and drag another one. And you see the icon changes to an overlay icon, indicating that I can let go of the mouse button and drop it on. So that's a little bit of fun and a neat way of creating overlays. We're going to look into these overlays in a little bit more detail shortly, as, for example, in this chart, the green overlay, which I put on last, pretty much covers all of the curves, so it makes it difficult to actually see the information about each of the curves underneath. We're going to change that shortly. Another thing to note is that after I've made changes to my graphs, these changes all appear in these thumbnails. So if I just wanted to get a graph of net income 3, if I click and drag and drop this chart, it's still the overlay chart that I created before. If I want to quickly undo all of this messing around that I've done, in the Edit and Export button of this pop-up is Reset All Graphs to Defaults. And now I've got my fresh start again. Now if I go back to that overlay and mention the problem that I had before, which was the chart itself didn't then look good enough for me to be able to analyze reasonably. If I grab these 2 sets of annual cash flows, we see we have an issue that I can't really get a lot of good information out of this graph. However, if I right-click my graph and select Graph Options, I can make lots of changes, not just to make this graph far more appealing and sell my story better, but specifically for overlays, I could change the formatting of each curve. This includes obvious things such as the color, but then also even more useful elements such as the style of graph and potentially performing an interpolation. So I'll quickly describe what those things are. If my net income for year 6 is my base or important figure, and then I wish the net income for year 7 to be a secondary part of the chart, instead of being thick bars, I could change that to a line. So now I have my year 6 standing out in my line curve, obviously as a secondary effect. If I want to change the title of my graph, one easy way is to simply click on it and I say net income in year 6 versus year 7. Great. Now I'll go back to my curve. Now these blocky histogram bars and lines, they're something, but they're not pretty. So instead of having bars and flat lines, I will change my graphs to be of a smoother nature. So I want my this red curve to instead be a solid, which now enables me to do an interpolation. So an interpolation between the points of the histogram. And so now it looks smooth and nice. And I'll do the same for the curve, that is Year 7 income. I'll change that also to a spline fit interpolation. And now I have two smooth lines. Much easier to see, much nicer to look at. Frankly, it looks more professional and so on. Nice and easy. There are lots of options in the graphing options section that, again, many people aren't aware of. This x-axis is probably way too big to be meaningful. It only needs to go up to 400,000. So I'll just go ahead and change that. Most of the features of these charts can be changed. We see colors, lines, x-axis. The y-axis in a probability distribution for a continuous function such as this is generally not useful to us. These values aren't useful, so I can remove them. Now no one can argue what do those numbers mean, because it's not a meaningful argument for us to have. So let's get rid of them. So right-click your graph options, and make changes to make this graph better. Do or don't like grid lines, you can remove them. Want the x-axis tick labels to be horizontal, make that change. You don't like Tahoma font, well that's the default, but we can change all of those things. Lots of different elements we can change here. One thing that I always do is I don't like the shading outside my vertical delimiter, so I can get rid of that. We can change the background colors and so on. So lots of things that we can do within any of the charts that Atrisk produces. Simply right-click, graph options, and have a little play. So that's a quick look at overlays and the graph options option. Next thing I want to look at is scatter plots. Now scatter plots are again very useful. We're looking at the relationships between variables or between outputs in our model, and we would like to graph those. Various easy ways of doing this. We can see in our results summary, if I just stay here, there is a scatter plot button. So if I get my net income for Year 2 and Year 3, I'm using the right-click option to create a scatter plot. It creates a scatter plot of those two variables and also calculates the correlation for me. If I grab multiple variables and ask for a scatter plot, I actually get overlaid scatter plots, where I have my first variable selected compared to two variables. Now here's another little trick that, again, very few people in the world, in fact, until this moment know about. When the chart has multiple curves in it, you can see that they actually get hidden to the right-hand side here. If we change the size of the graph, it still has those things hidden. We can scroll to see them, but better it would be to be able to move this and open up the statistics pane. Well, we can. You can't see what I'm doing, but if I press and hold the Control key, I can slide just the outer window, enabling me to show the information for the multiple curves that are on the graph. In this case, the multiple scatter plots. So I've got two pairs. So that's pressing and holding the Control key to get the graph window to easily show the information you'd like it to. So I could get scatter plots between inputs, again to potentially show me what any dependency or correlation is between them. Scatter plots between outputs. But even more usefully or more commonly, I will want to get a scatter plot of an input versus an output. There are several ways of doing that, but one very easy way, pardon me, is from the sort of result that we're probably going to be interested in the first place. So if I look at my MPV, here is my output, and I get a tornado chart, say a regression tornado. And I would like a scatter plot of one of these, pardon me, one of these variables compared to the output. I can click on the tornado bar itself, drag, and you can see the scatterplot icon that appears, drag and drop, and I now have a scatterplot of that variable compared to my output. I can do this for any variable from any tornado chart. So maybe I'll get the sales volume, click and drag. And now I have a scatterplot between the sales volume in the 8th year and the MPV. I can see the calculated correlation, both Pearson and rank, for these variables. So click on a tornado bar and drag it off. Now this produces these scatterplots, for both if I'm looking at regression or correlation tornadoes. But something very neat happens when I'm looking at the tornado for the inputs ranked by their effect on an output statistic. If I'm looking at an output statistic chart, I have a double-sided tornado. Now the way the output statistic charts work, I use the spider to help explain, is the inputs are cut up into percentile bands. By default it's deciles, so 10%. And for each 10%, the simulation data is filtered and the mean or other statistic of the output is calculated for that decile. These points are tracked, and the extremities from the highest to the lowest, if I'm just looking at, say, the yellow curve here, those extremities are the width of the tornado bar. Okay. Now, this spider helps explain where the tornado comes from. But if I look at the tornado and collect, say, sales volume, if I click and drag and get this scatter plot, it helps to, again, explain how I get these results. The deciles with the highest and lowest expected value for my output have been color-coded, so highlighted here and here. Green dots and blue crosses on top of the regular scatter plot. So this is the same scatter plot that we saw before, but now it's been color-coded to show, okay, well, these values return for me the highest expected value for the output of all deciles in my input. And this decile, which happened to be the lowest sales volume, not surprisingly, had the lowest expected value across those deciles. Okay? So when you create a scatter plot out of the change in output statistic tornado, you get another piece of information again to help explain what can otherwise sometimes be a confusing report or a confusing chart, especially for those who aren't familiar with change in output statistics. Another little trick or tip I can show you, again on the graphing idea, is if I have correlated variables, or I'm thinking of correlating two variables such as these. If I put in a correlation coefficient, that's great, but what does that actually mean? Well, it's difficult to say what 0.8 means, especially compared to another value such as 0.4. It's not twice as correlated, it's just more correlated. So a way of helping to understand what these values are is, of course, a scatter plot for them. So the third button from the bottom is Show Scatter Plots. Here is a rough scatter plot, if you like, of what the relationship between those would look like if it were a 0.8. If I generate the scatter plot, a bigger scatter plot of that by clicking on this thumbnail and dragging, I get a more detailed scatter plot that includes quadrant analysis. So I can look at the proportion of results in certain regions, such as if this variable exceeds 60,000, roughly what proportion of my product development costs will also be, say, below average. 15.5 plays 0.5%, and I can get that, pardon me, I calculate that as a ratio. So these scatter plots also give us quadrant information, where I can move my two delimiters up and down to different values of interest to get this information about these sectors and where those data points will lie. Now, something that you will have noted with these various charts that we're creating is, and as you know, every time you create the first one, it always looks the same. If I get a graph of an output, it looks exactly like this. It is red, it is a histogram, it has the two vertical delimiters set at the P5 and P95. pardon me, and it is always looking like that. Now, this means that all of the standard reports that you create also look like this, pardon me, and you might find yourself always having to change every graph to show the P10 and P90 rather than 5 and 95. Or maybe as an organization, you always look at the P50 and P75. There are various reasons why, as a company, you might have different standards for the sorts of information you always want shown on a graph. Now, you do not have to go and change every single output graph after a simulation to get these sorts of things happening. There are lots of settings in at-risk that can be affected. Let's go back and put this to the default. That can be affected permanently by changing the default settings themselves. So under Utilities and Application Settings, I can now make permanent changes in this workbook or in a brand new workbook to the way at-risk will run. So if I just look at the first example that we discussed, which was the curves, why are they always red? Just because that's the default. If I want them to be a different color, such as horrible green, I click OK. Now when I ask for a chart, it should come up in that horrible vibrant green color. My apologies if that's your favorite color. It is pretty stark. It certainly would make an impression in a meeting. Now what else can I change? Usually it won't be the color that's of most importance to us. It'll be the information shown on it. So if I go to my graphing defaults, the vertical delimiters are 5 and 95 just by default. If I want those to always be 50 and, say, 80, again, now when I ask for a graph, it will show me the P50 and the P80 every time. So I can set that change in this model, and I will always get this sort of outcome. As you've probably seen in the background here, there are lots of things that I can change. If I just focus on my graph defaults for a moment, all of these options can be included. Potentially, I would like to never display the y-axis rather than always turning it off every time I create a chart. Maybe I don't want the legend. Pardon me. Maybe the x-axis tick label orientation, I want that to always be horizontal so I'm not turning my head to read off the numbers. I can make those changes here. Okay? Now, not everything can be changed in this dialog, but as you can see, a lot of things can. What else can we change in our application settings? There are a few options in the general section here that we will often change. When you first install at-risk, of course, you get the welcome screen appearing whenever you launch the product. The welcome to at-risk. Now, after you've seen the welcome to at-risk a few times, you probably don't need to see that again. It can be turned off here. It's the sort of thing that can also be changed here. Welcome screen, change it to false to make sure it doesn't get shown. There are other more important things to potentially switch off, such as saving results. We all know that if you run a simulation and then save the file, by default it asks, would you like to have that data stored with the workbook? Now, for a lot of people who run very big models, it's detrimental to be storing 100, 150 meg worth of data in the file, because then we will be unable to email the file and so on. So rather than always clicking no, you could change the prompt to never save. So now when you save the results, or when you save the file, it by default won't be asking you, do you want to save the results, do you want to save the results, do you want to save the results? However, perhaps you always want it to save the results. So you don't want to be asked because you're always clicking yes. So you might change it to automatically save. Or you can also select to save to an external file. So your simulation data doesn't need to be stored in the workbook. It can be stored in a .rfk5 formatted file. It's a at-risk's own database. And so it can be, you can save all of your data, but have it stored external to the model. And when you open up the model, you can open up a particular data file for a certain run, and you'll have all of those simulation data and therefore results available to you. Now I'm going to go back into our application settings shortly, but I'd like to show you another reason to go and use the default options to make some changes. Now if I go to my product development costs, a truncation function, which truncate, has been included in this distribution already. So if I now want to put a distribution in, sorry, a truncation in, I can. But if I simply open or define a new distribution, which I can also do by the mini toolbar, so I'll show you that way. I'll define a distribution for this cell. If I ask for, say, a normal distribution, the option for including truncations is not there. To then put a truncation in now, I would need to select parameters, change them from standard, and then include a truncation limit as an option. So now I can put in a limit at, say, -5, and I'll also include an upper limit at 20. So now I have my truncations. But that took a little bit of work. I had to put that in there. If I click OK, it goes onto my spreadsheet. And now I realize that I would actually like to also use a static value to ensure that I can control what is shown in that cell when a simulation is not running. So I want to show the number 5 in that cell. To make or to include a risk static function into this cell, I either need to go through the same process with defined distributions or insert the property function that is risk static. It puts in a dummy value for the static argument. So now I can go in and make it a 5. It's a bit of a manual process. For those who aren't super happy or comfortable using Excel functions and editing them and so on, that can take a little bit of work, and it could be a hassle. It could also lead you to make some mistakes. However, that seemingly is they're the only ways to get truncations and statics into your distribution. If you're going to use truncations or static values a lot, it would be much easier if those options were already there. So one very useful application setting that you might consider including is distribution entry, truncations, always display, and I'll also always display static values. Click OK. What this means is when I go to define a distribution, and I pick a normal function again, now I have the optional truncations and static arguments here ready for me to choose. I don't have to, of course, because they are optional. But if I want to put in truncations, I can without going through those processes I previously mentioned to include them. A lot of our clients, especially with truncations, need to use these quite a lot. So this takes away a lot of legwork, if you like, or click work to get those put in there. Pardon me. Something else that I might be interested in is creating a report for my output. A very common report will be a quick report. Various ways of getting to the quick report, but if I want to, pardon me, create a quick report, where will it go? By default, the report will be placed in a new workbook. But perhaps I want my reports to go into the active workbook, and maybe I'd like to store each version of my reports as well. So I'll go to Utilities, Application Settings, and look at my report options. Where should the reports go? New workbook, active workbook, and should they, say in the active workbook, overwrite the existing report? Or if I'm building collections of new reports, do I want them all to go in a new workbook or into their own workbook? So I can make those changes there. I'm going to reset all of my application settings now just to go backwards to go forwards. For those of you who are already using reports such as the quick report, you will know that they always come out looking the same. So if I start from a graph of my output, and then I select the Edit and Export button and Quick Report, it builds a quick report of this output. The graphs, be they the histogram, S-curve, and the sensitivity chart, will all come out in their default settings. So the traditional defaults of P5, P95, the new standard default, sensitivity analysis, is the inputs ranked by their effect on the output mean, and so on. Now, again, if we look at this report, it always comes out in this format, so I cannot now go and adjust my vertical delimiters to the, say, 50 and 90 that I would like to show, or the 60 and 90 that I would like to show. However, these reports are a direct result of, or based on, or caused by your application settings. So if I change my application settings and change my graph settings inside that, change my delimiters to 50 and 90, and I will also change my, say, standard sensitivity report to not be changed in output mean, but I will get a correlation tornado instead. Now if I ask for a quick report, we should see those changes shown in the quick report itself. So as it comes up, the P50 and the P90 are now where the default delimiters lie. And also, the tornado chart is the correlation, or the sensitivity chart is the correlation tornado. Okay, so if I don't want to have change in output mean as the default sensitivity result, I can change that. Okay. So I'll put that away. One more thing that I'll quickly show you in the default options, which is commonly used. For those of you who do use the software a fair amount, especially in project cost estimation or any field where there's a lot of estimation, hopefully, especially if you've done our training already, you will be using alternate parameters almost all the time. By default, the alternate parameter options are P5, P50, and P95. These are the arguments that you need to include. But you aren't stuck with these values. The worst way, if you like, or the least elegant way to change them would be to build the function and then manually edit these percentiles in the cell. We could also go to the alternate options and change the percentiles here. We can also mix and match percentiles with standard parameters as well. But again, if we are always going to model using P10, P50, and P90, we don't want to have to make that change every single time. So we can change those defaults for individual distributions in our application settings in the alternate parameter default section. So we can pick a distribution, I was on log normal before, and then change the percentiles here. We can also, for those organizations who look at numbers backwards, if you like, use descending percentiles so that the P90 is actually the small value and the P10 is the larger value. You can make those choices here as well. Again, just looking for ways to help make life a little bit easier. Let's put that file away. If I start with a blank workbook, let's look at some defined distribution options. Now, for the most part, we use this dialog. We grab a function, the thing that we want, we put it in, easy. There are lots of things that we can do within this dialog, however, to again make our lives a little bit easier. The first one is a comparison. If I select a log normal, I might be interested to know what a gamma function might look like on top of that. Well, very simply, I can select the overlay button and choose a little version of the distribution window appears. I'll grab a gamma, and now I have a gamma overlaid on top of that. And I can change my parameters to try and get, let's actually change that to 5, so I get a mean of 10. So now I have, I'm going to use my little control key cheat from before to just slide out the statistics half of the window. Pardon me. And now I can compare these two charts, maybe look at the tail percentiles that are included here and see which one best matches my needs. Okay. And I can overlay several charts on this. I'll put this away for now. I can overlay several charts to help choose between charts. I can then also get rid of any charts that I don't like. So if I delete my log normal, I'm left with my gamma function. If I decide that I want to change away from something apart from the gamma, I can just hit my little delete curve. Because there are no curves left, it takes me back to my defined distribution window. If you click once on any chart, you'll also see that a little question mark appears in the corner. Little question mark. If I click that question mark now, it takes me to the help file for that particular function. All of our functions and pop-ups and so on have help files in them. But the easiest way to get to the help files for a particular function as you're looking at it, or a distribution in particular, is to use that little question mark. So it gives me the mathematics, some of which will be useful to me, some not, but then there'll be a little description, and also for some of the more complex functions, a description of the parameters themselves to get an idea of what that curve is commonly used for and what it does. Obviously, functions that have a long and rich history, such as the Gaussian function or normal distribution, has quite a big description. Others won't have as much information, but it's still a good way of getting an idea about what we're doing. Because, as you all know, there are a lot of distributions, and deciding between all of these things can be a little bit tricky. It's also common practice, however, to have a few distributions that we use over and over again. Pardon me. So a good way to then operate once you've made the decision about what is that short list is to put all of those distributions into the favorites tab. By default, the favorites is blank, but let's say we were going to look at the log norm alt and pert alt as being two distributions we're going to use quite a lot. So I select the log norm alt by clicking it once and then simply make it a favorite. And it puts it in my favorites tab. And I'll also do the same for the pert alt and perhaps a few discrete distributions such as the binomial and Poisson. So now whenever I define a distribution, it will probably be one of these, so I can go straight to the favorites tab and pick it. Okay. It's also useful in terms of a process for you to set this up and everyone knows to pick something out of the favorites tab. Don't jump over here and go for a log logistic alt because you potentially don't know what you're doing. Okay, it just makes it easy to navigate amongst or around all of this stuff. Put it all in the same place, and perhaps also use the compound function. So for people who are doing risk register type modeling, these 5 functions will be used 95% of the time. So if we put them all in the one place, once we've started going to the favorites tab, by default, at-risk will always pop up in the favorites tab, so we can then just go straight to the functions that we want. Again, just making your life a little bit easier. Now, I do get asked quite a lot, how do I share my models or results with other people? So results are very easily shared using reports. These will be native Excel formatted reports, easy to get around and so on. But if someone actually wants to look at the model and they don't, pardon me, have at-risk on their or in their spreadsheet, or as an add-in loaded, of course they see nothing but errors. Okay, the at-risk functions are completely unknown to native Excel, so it looks like a name error. If I were to just open this file, there would be name errors in all of my inputs and therefore in all of my outputs. Not a good look. So if I want to share this with someone, what I really want to do is remove all of the at-risk functions, but not permanently. So we use the swap out function. I swap out the functions, and now all of that functionality appears to be gone. There are no output functions, no input functions. There would also be no statistics functions or results functions. Everything that starts RISK is now effectively gone. I can save this file, email it to a manager or a client, somebody who wants to look at the model. They can open it, maybe make some changes to the parameters, update it, save it, close it, email it back. I'll launch at-risk and then open the file, and at-risk will know that there are swapped out functions and will automatically pop up and say, do you want me to swap them back in? I click OK and in they go. So it remembers where all of that at-risk functionality was. If someone has overwritten one of the cells that used to have an at-risk function, maybe the CapEx now reads 13 or 1.3 million. When I swap in, I'll be told that cell was edited. Do you want to use that value? Perhaps the risk has been realized. Do you want to include that as a static but keep the old function? Or maybe just swap back to the original function and calmly remind the person you emailed it to that they weren't supposed to edit those cells. Either way, we've now made our choice and we've been notified. Of course, it's possible to delete enough of the workbook that you can't recover the work. You know, nothing is totally foolproof. But if someone simply types over these cells, you'll at least know. Another way of sharing my results, and this is especially useful if I'm in an organisation with a, pardon me, a network license, is with the at-risk library. The at-risk library, for an individual user, enables you to store input functions that maybe you've worked on and you've put a bit of time in building and you want to use in multiple models. You can store them in here, so you always have access to them via at-risk. You don't need to have that original spreadsheet open. Likewise, simulation results can be stored in here. Anywhere you see the library book icon, you'll be able to store that thing in the library. The neat part about the network license is that this at-risk library, which is an SQL database, is actually shared across that network. So I can run a simulation, put some results in here, and then other users can access those results. Likewise, if I'm the market share or interest rate or oil price or whatever expert, and I build a particular model for that, for consistency, I want everyone in my organization to use that same model. Maybe it's a distribution. What I want is for everyone to use that one and perhaps also not actually edit the library. So what I can do is I can store it in here, I can password protect it, so when other users open their version of at-risk and open the library, it's available to them to then drop into their own models, but they can't edit this. So it stays as a the perfect version of the function that I wanted to use, or that I want to share with people. So that's the at-risk library. It's useful for desktop versions. It's especially useful for network licenses. Pardon me. Something else that is of a lot of benefit, especially in the cost, project cost world, but across any environment. I was working last week with an environmental biologist who also was able to use this functionality looking at contamination. So it's got applications as broad as at risk. And that is the need to understand what it is that you've created in your inputs. It's easy enough to build an input distribution, but then to actually check that it's doing the right thing, that can be a little bit harder. So for example, I have my year one oil production distribution here. I've been given some parameters, but is there other information about it that I might want to know? I can find out, pardon me, things like minimum or maximum values for distributions or different percentiles that help me understand how reasonable or not my distribution is. And these are known as the theoretical functions or the risk CO functions. And they are all fairly easily understood: max, mean, min, percentile, and so on. So I'll grab, say, the minimum for this log normal. Now, being a standard function, sorry, standard log normal, the minimum I know will be 0 until I said that it's 0. Also, being a log normal, it has no maximum. So if I put in a risk CO max function, it returns an error because it's undefined. So because it is undefined in the tail, but I want to know tail information, I'm going to use a risk CO percentile function to let me know what the P95 is. And I will use some absolute referencing to make sure I could copy and paste this down if I wanted to. 46,000. So now I have some idea about how far the tail goes out. Especially, I mentioned that the cost world, but any physical world, often negative values aren't feasible. However, it is possible to create functions that have all positive parameters but still return a negative minimum. So for example, instead of, if I look at my year 1 gas production here, instead of being a log norm, if I instead replace this with a log norm alt with 3 parameters, low, mid, and high, say 5,000, 25,000, and 50,000 as the low, mid, and high parameters, I then now define a log norm alt function in that cell. Oh, actually, here we go. I'll use my favorites. Log norm alt. Low, mid, high. Click OK. Now, if I use my risk CO min function, I'll just copy and paste that down, I can see the minimum is actually minus 75,000. So I have positive values here, but again, not a lot of people realize that a log normal is only has a minimum of 0 under specific circumstances, when you've defined it as such. Its minimum can be any value in reality. So I could go to the graph of each of my functions to find out this sort of information, or simply use risk CO functions to tell me automatically what's the minimum of all of my curves and to make sure they're still reasonable. The normal functions, of course, have no minimum, so it's a neat reminder that these can be as low negative as can be sampled by Excel and at risk. One more thing that I will include now as a bit of a wrap-up for today's talk is just some general usage of the software. So when any of our products are open, whenever they're loaded, you can launch another product from within Excel. So maybe I want to go and open Evolver now. So from at risk, I go to Evolver. All of our products are able to be opened simultaneously. There are no conflicts there. And so now I can get these results. I don't need to go out of Excel, maybe go to the desktop, which might be messy like mine is, or go through the Start menu to try and find the software. I can do it there. I can also unload at risk without having to actually close Excel itself. If people who've been using the software for a while know that used to be the case, the only way to get rid of our add-ins was to actually shut down Excel. Maybe you don't want to, you just like to unload the add-in, well, you can. So now at-risk is gone. I've still got Evolver sitting there, but I haven't had to shut down my Excel session to get that sort of thing done. What I will do is reopen at-risk. We talked before about the option to store data. So I've got my welcome screen. Let's get back up because I made that change. To store data with your at-risk workbook. So if I grab an example file and I run a simulation, if I go to save that, I can store the data with that file. Just save this file. It's in a save as, so let's go and put that on the desktop. There is 3 meg worth of data here. So I save it to the desktop. It now has all of this data. If I close this file and reopen it, it will still be there. I'm not stuck with that, however. Under Utilities, once again, I can clear at-risk information. The most common thing to get rid of is simulation results. But I can also go all the way to removing absolutely everything to do with at-risk from this file. If I just clear the results, you see that I currently have simulation data stored. Once I've cleared it, it now goes away. So maybe I accidentally stored 120 meg worth of data in my file. I can actually clear it, and now it's gone. I've gone back to my original size file. Okay, so we're going to wrap it up there for today, guys. Just a reminder that this webcast will be available on our website soon, hopefully in the next week or so. I hope you got something out of those little tips webcast. It's those little things that make your working life that much easier, as you know. So it's good to have as many of those little things in your arsenal as possible. And I know that a lot of people don't know how to do these things because I get asked by clients, or I get a complaint or a comment from a client that it's a shame that I can't change the default vertical delimiters in at-risk. Well, probably you can. Just a reminder that we have upcoming a continuation of our optimization webcast. We've got another one on Evolver next week. And we've also got some of our East Coast here in Australia user conferences coming up. So hopefully I get to see you all then. Hope you've enjoyed this little session, and I look forward to speaking with you again soon.